Hello everyone. My name is Reo Morishige, and I'm from Hiroshima City University. Today, I'm going to talk about on the acceleration of data packet dissemination by considering terminals processing load in crowded environment for Bluetooth MANETs. Let's begin. First, I will explain about Bluetooth and MANETs. Before explaining about Bluetooth MANETs, this slide shows Bluetooth. Bluetooth is a connection-oriented short-range wireless communication standard. Therefore, the terminals must establish connection in advance. Let's look at this picture. In the connection establishment process, when one terminal sends connection request and the other terminal accepts the request, the connection is established between the two terminals. Then, I will explain about MANETs. MANETs are wireless networks composed of mobile terminals and communicate without using communication infrastructure such as base stations. Then, Bluetooth MANETs are MANETs using Bluetooth for communication between terminals. There are two advantages of using Bluetooth. First, Bluetooth is a low power consumption. Second, Bluetooth is resilient to radio wave interference. An example of the use of Bluetooth MANETs are the communication method at the time of disaster. Bluetooth MANETs has been studied based on the practical experiments and the simulation experiments. In practical experiments, we have experimented with a small number of terminals, about 2 to 5 devices, and only evaluate the performance of simple topologies such as line topology. On the other hand, in simulation experiments, we have experimented with a large number of neighboring terminals and evaluate the performance of complex topologies. However, the simulation experiments cannot consider the processing load of the terminals. In practical experiments, we must evaluate the performance with a more complex topology using more terminals than in existing research. So, we conducted a preliminary experiments with increasing the number of terminals. Specifically, we conducted communication experiments with a complex topology using 10 terminals and investigate the impact of increasing the number of terminals. The communication system used in the preliminary experiments are Bluetooth MANETs communication system that runs on a Linux OS-based Raspberry Pi. This system is called the existing system. This picture shows an experimental configuration with 10 terminals. We emulate crowded environments. This table shows the specifications of the Raspberry Pi used in the experiments. This table shows experimental parameters. The number of trials is 30. The number of terminals used in the experiments is 5 and 10. The number of terminals sent data packets is the same as the number of terminals used in the experiments. The number of sent data packets for each terminal is 30. The experiment time for each trial is 180 seconds. These are evaluation items. First, we define the data packet dissemination ratio. This is percentage of data packets spread across the networks. The definitions are as like this. Second, we define the number of established connections. This is the number of connections established by one terminal. The definitions are as like this. Let's look at this graph. This graph shows the average data packet dissemination ratio per trial over time. The x-axis shows the elapsed time, and the y-axis shows the average data packet dissemination ratio. The blue line shows the 5 terminals, and the orange line shows the 10 terminals. The error bars shows the 90% confidence interval. These results show that the average data packet dissemination ratio decreased by up to around 50% at the same time in 10 terminals. Then, this graph shows the average number of established connections per trial. The x-axis shows the number of trials used in the experiments, and the y-axis shows the average number of established connections. The error bar shows the 90% confidence interval. These results show that when the 5 terminals, the average number of established connections was around 6, and when the 10 terminals, the average number of established connections was around 8. Therefore, the increase in the average number of established connections was around 2. The results of preliminary experiments show that when the 10 terminals, the speed at which data packets are spread to the terminals becomes slower, and the possibility that the increase in the average number of established connections was insufficient for the increase in the number of neighboring terminals. Due to the increased processing load of the terminals, it is considered to be difficult for the terminals to establish new connections. Problems in the existing system as seen from preliminary experiments is the terminal continues to maintain the connection. Let's look at this graph. The orange circle shows the terminal, the black line shows the connection, and the blue arrow shows the connection request. Terminal S establishes a connection to multiple neighboring terminals. Terminal S continues to maintain these connections, which increases the processing load. At this point, a new neighboring terminal appears and sends a connection request to Terminal S. However, Terminal S rejects the request because of the increased processing load on Terminal S. Thus, when the number of neighboring terminals increases, some terminals cannot establish a connection and cannot communicate. Therefore, we saw that if a terminal does not maintain the connection, the processing load of the terminals does not increase, even if the number of neighboring terminals increases. So, we propose a connection method that establishes a connection only during data transmission. I will explain about our proposed method. Let's look at this graph. The orange circle shows a terminal, the black line shows a connection, and the blue arrow shows a data transmission. First, establish a connection between the terminals. Next, the terminals transport the data. Finally, the terminals disconnect the connection. Connection establishment, data transmission, and disconnection are repeated for multiple neighboring terminals. Therefore, in our proposed method, the terminal does not maintain the connection, which reduces the processing load on the terminal. I will explain about communication procedures in our proposed method. Let's look at this graph. First, establish a connection between terminals A and B. Next, the data exchange between terminals A and B starts immediately. Next, assume that terminal B completes the data transmission first. Terminal B sends a packet to terminal A to indicate that the data transmission is complete. This packet is called the transmission completion packet. Next, Terminal A receives the transmission completion packet from Terminal B. However, Terminal A does not disconnect the connection because the data transmission is not yet complete. Next, Terminal A completes the data transmission. Terminal A sends the transmission completion packet to Terminal B. Finally, Terminal B receives the transmission completion packet from Terminal A and disconnects the connection because Terminal B has already sent the data. To investigate the effect of our proposed method, we conduct the communication experiments. So we implement a communication system based on our proposed method and the existing system on the Raspberry Pi. We have evaluated the communication performance of both systems. This table shows the specifications of the Raspberry Pi used in the evaluation experiments. This table shows experimental parameters. All experimental parameters are the same for both systems. The number of trials is 30. The number of terminals used in the experiments is 10. The number of terminals sent data packets is 10. The number of sent data packets for each terminal is 30. The experiment time for each trial is 180 seconds. These are evaluation items. The evaluation items are the same as in the preliminary experiments. Let's look at this graph. This graph shows the average data packet dissemination ratio per trial over time. The x-axis shows the elapsed time. The y-axis shows the average data packet dissemination ratio. The blue line shows our proposed system, and the orange line shows the existing system. The error bars shows the 90% confidence interval. These results show that the average data packet dissemination ratio increased by up to around 23% at the same time in our proposed system. Then, this graph shows the average number of established connections per trial. The x-axis shows the number of terminals used in the experiments, and the y-axis shows the average number of established connections. The error bars shows the 90% confidence interval. These results show that when the existing system, the average number of established connections was around 8, and when our proposed system, the average number of established connections was around 11. Therefore, the increase in the average number of established connections was around 3. Experimental results show that increased in the average number of established connections in our proposed system. Therefore, the speed of data packet dissemination faster than the existing system. Future issues include communication experiments with the number of neighboring terminals is increased, and measuring the processing load of the terminals. To sum up today's talk, when the number of neighboring terminals increased, the increased processing load on the terminal, and some terminals cannot communicate. In addition, we confirmed the speed of data packet dissemination becomes slower. Therefore, we propose a communication method that does not maintain the connection. Our proposed method reduces the processing load of the terminals. In addition, we implement the communication system based on our proposed method on the Raspberry Pi. Through evaluation experiments, our proposed system increased the average number of established connections and realized faster speed of data packet dissemination. Thank you so much for your kind attention.